So what we got last, that redshift occurs when the stars are moving away from from the observer. Basically, we are observing from the Milky Way galaxy. So all other stars, whoever we are studying from our Milky Way, from our Milky Way, are appearing to be redshifted. That means everything is moving away from each other. Okay. Now you might be asking that why does what about the concept of spectrum? So you see, suppose that there's a star. Okay, so I told you the star has various elements: hydrogen, helium, lithium, beryllium, like that. Okay, so you know that every element gives some emission, isn't it? Every element is gives some emitting. Emission means you know that this is suppose the ground state, then this is the first excited state, second state. So whatever, suppose there is an electron here, he comes down to this. So when it is coming down, the energy difference between this will be emitted as a particular frequency that is called h nu. So that is nothing but sc by lambda. Are you getting? So whenever you see a stellar spectrum, you will always get to know about the and every element, hydrogen, helium, lithium, beryllium, they emit at a particular frequency. Suppose if hydrogen is emitting, nu will be different, lambda will be different. Similarly, if helium is emitting, nu will be different, lambda will be different. So every element has a separate wavelength of emission. Okay, so for that, let me show you something. How does it appear? Suppose that this is the continuous spectrum of a star. So you know that red is the highest wavelength. Okay, let this V. Okay, so I will consider red, green and blue. Okay, then suppose I need green color. So this is green color. Okay, and then this is a blue color. Fine. So B, G, R. Fine. Suppose that this is the situation at the star. Okay, fine. This is what the star has emitted. So lambda emitted. Okay, and you know what happens in that thing? These elements, I told you that they are emitting. They usually emit. These are the emission lines. Okay, but at a certain frequent wavelength, they will be absorbing also. Fine. Suppose these are called absorption line. They're absorbing the light. That is why you see they are not what I can say, they are black. They are not emitting, they are absorbing. So these are called absorption lines. Okay, so they are at a certain frequency, say lambda 1, lambda 2, lambda 3. These are the wavelength at which the absorption occurs. Okay, this is characteristic of this element, hydrogen, helium, lithium, beryllium. Okay, fine. Now suppose that you are on earth now. So somebody is there on earth. So somebody is standing on earth and somebody is watching this particular thing. So he is also going to see that particular, what I can say, spectrum, isn't it? So if I just consider that I'm drawing in an equal, but if they may not be, I'm not drawing that comfortably, you can understand. So this is the thing, so red thing. Okay, so then we have the green thing. Okay, and we have the blue thing. Understood? So this is what lambda observed on Earth. Understood? So this same spectra you are supposed to get. But interestingly, what Hubble has seen that, can you see this absorption line? So according to rule, what should be there? It should appear here. According to rule, it should appear here, and according to rule, it should appear here. The red portion is a little bit less. Let me draw it properly. Okay. So what happened, Hubble observed that these absorption lines were slightly shifted. See, they are shifted. They are supposed to be here, but they shifted to this. They are supposed to be here, they shifted to this. They are supposed to be here, so they shifted to this. So they shifted towards what? They shifted towards red color. Are you getting? So shifted towards red color. Are you getting? That means whatever the star is emitting, this is a normal emission line, lambda 1, lambda 2, these are the absorption line. Absorption line is a characteristic value for each and every element. Fine. But when you receive the starlight here on Earth, is it the same? No. The absorption lines got little bit shifted, and they are not towards this direction. They shifted towards the red direction. So this what Hubble have connected it to Doppler effect. Okay, and Doppler effect tells us that the wave red color means lambda is high. Is it? So lambda will be high, frequency will be low only when the source is moving away from the observer.